Okay, so I'm going to spend 2 days on arc and angles. So today's part 1, and we're going to model and solve problems using arcs and angles. And we're just going to learn some theorems and some vocabulary that should help you out. Okay, so the first thing we're going to talk about is central angle. So a central angle is an angle where the vertex of the angle is at the center of the circle. So B is the center of the circle. It's also the vertex of the angle ABC. So the measure of ABC is equal to the intercepted arc. So an intercepted arc is the part of the circle that the angle cuts off from the rest of the circle. So in red is your intercepted arc. Intercepted arc. And in purple, that is your central angle. And the thing that you have to know about them is that they're equal to each other. So let's say that I knew the measure of the angle was 70 degrees. Then I would automatically know that the arc was also 70 degrees. So that's all you have to know about central angles. Okay, so here's another vocabulary word. This is an inscribed angle. An inscribed angle is different from a central angle because of the vertex. So notice that the vertex of ABC is on the outside of the circle. It's not at the center. That's why I know this one is an inscribed angle. And here's what I need to know about this. So an inscribed angle is equal to half of the intercepted arc. So here's the intercepted arc in red. And then in purple is my inscribed angle. And so let's say that this time I knew that the angle was 70 degrees. The angle is half of the arc, so the arc would have to be 140 degrees. So that's the difference between those two. You have to know the vocabulary, and then you have to know the rule that goes around with them. So you have to know the central angle has a vertex at the center, and a central angle and an intercepted arc are equal to each other. And then for inscribed angles, the center of the angle is on the outside of the circle, and you have to know that an inscribed angle is equal to half the intercepted arc. So that's the difference between those two. Alright, so this first one I think is kind of like a duh formula, but some people have trouble with it, so I'm going to highlight to see if I can help you out a little bit. So we have this angle ABD. And then we have this other angle ACD. And if you'll notice, they are both intercepting the same arc in red. So if you look at the blue angle, it's intercepting that red arc. But if you look at the purple angle, it's also intercepting the red arc. So both of those are going to be congruent to each other. So like, let's say I knew the arc was 120. Then that blue angle I would have to know is 60 degrees because it's half of the intercepted arc. But the purple angle is intercepting that same 120 degrees, so it would also have to be 60 degrees. So that's how I know that the blue and the purple angle are going to be the same thing. So I don't think it's too hard to remember. Alright, and then the last thing that we're going to talk about is an inscribed quadrilateral. So remember, quadrilateral means 4 sides, so we have a 4-sided shape in here. And the only thing you have to know about these is that opposite angles that are across from each other are supplementary, so they're going to add to be 180 degrees. And then also, if you looked at B and D, they're across from each other, so they also have to be 180 degrees. So I think those formulas are pretty easy to remember. So we're going to look at some problems. So one of the first things that I want to caution you on is making sure that you actually read what you're looking for. So I'm going to kind of do this. I'm going to try to color code it for you. So the first thing that we're going to find is the measure of arc ST. So that's this arc right here. So it wants us to find this. I'm going to circle it in purple. The next thing it wants us to find is the measure arc RS. So I'm going to do that in yellow. And then the last thing that we're going to find is this big arc RST. so I'm going to talk about a few things. The first two things that it asked us to find, those are minor arcs. I know that those are minor arcs because they only give me 2 letters. So anytime you have a minor arc, you're going to have an arc that's less than 180 degrees. So just from the simple fact of seeing 2 letters, I know that my answer is going to have to be less than 180. But then the one in blue, they're giving me 3 letters. That is a major arc. So I know my answer is going to have to be more than 180 degrees. So that's just some things, some little things that you need to know, and that can help you out when you're trying to find the right answer. Okay, so what we have here, we need to figure out if we have a central angle, an inscribed angle. Are we talking about overlapping arcs, or are we talking about an inscribed quadrilateral? So the first thing that I see, and I'm going to do it in green, is this angle SQT. It is a central angle because the center of the angle is at the center of the circle. So from the formula, I know that a central angle and an intercepted arc inside of it are going to be equal. So I automatically know that this arc is 122 degrees also. So I don't have to do any type of math, just recognizing that that was a central angle and knowing the rule, I can figure it out. Okay, so now I'm going to find the measure of RS. I see, and hopefully you do, that from here to here is a semicircle, and I know that a half a circle is equal to 180 degrees. So if I do 180 minus 122, I get 58, which means that this little piece over here has to be 58 degrees, because 58 plus 122 gives me 180. Alright, and then kind of the same deal, I have another semicircle right here, so this is 180 degrees, but I want to find from S to R to T. So from S to R is 58, and then from R to T is 180. So I just add those together, and I get 138. Alright, so if you'll notice, the first two were minor arcs because they were only 2 letters, and they are both under 180 degrees. Oh my goodness, look at what I just did. Oh, I wish y'all were here to yell at me. I subtracted. That's embarrassing. I was totally testing you. Okay, I wasn't. Alright, let's try that again. Alright, and then the last one was 3 letters, so it was a major arc, and it had to be more than 180, which it is, which is how I knew I messed up and looked back at my answer. Okay, totally did that on purpose. I'm such a great teacher. Okay, embarrassing. Okay. Alright. So, lots of things you can do in this one. I would suggest that you actually read what you're looking for. So, I want to find the measure of R to S to T. So, R, S, T. Okay, that angle is an inscribed angle. I know that because the vertex is on the outer edge of the circle. Some other things I know is that a whole circle has to equal 360. So if I know that this part is 64, this is 139, and this is 75, I can subtract all 3 of them from 360, and I can get this measure from R to T really quick. For instance, if I do 360 minus arc 64 minus 139 minus 75, I get that remaining arc is 82 degrees. So I'm going to write 82 degrees over here. Okay, I wanted that because I recognize that this is an inscribed angle, and I know that an inscribed angle is half of the intercepted arc. So now that I know that that arc is 82, half of 82 is 41, which means that this is 41 degrees. Okay, so hopefully that made sense. And then, if you'll notice, I'm looking for RUT. And the nice thing about this one is that that is intercepting the same arc of 82 degrees. So this is also 41 degrees. So they were intercepting the same arc. They had to be the same angle measure. So just from finding the blue one, I automatically know the purple one. So hopefully that makes sense. Okay. Let me make sure I didn't skip anything. Okay. So we're going to do this one really quickly. So if you'll notice, this is an inscribed quadrilateral. It's a 4-sided shape. I need to know that quadrilaterals, opposite angles are supplementary. Just look at all the rules that we talked about at the very beginning. So sometimes I think the hardest part is just figuring out where to start. And you may not start in the right place, but it's going to be okay. So here's what I'm looking at. This angle right here and this other angle H, I know have to add to give me 180 degrees because opposite angles are supplementary. The other thing that I know is if, I'm just going to draw this one all the way. I also know that angle H over here is an inscribed angle because the vertex of the angle is on the outer side. And inscribed angles are equal to half of the intercepted arc. So that intercepted arc I just drew in red, the whole thing is 50 plus 96, which is 146. So if I know the arc, the red arc is 146 degrees, then I know that half of that is 73. So angle H has to be 73 degrees. Okay, so from then, I know that if I add the green and the yellow angles, they have to add to give me 180. So the green angle is 12x minus 25, and the yellow angle is 73. And from the rule that we talked about at the beginning, I know that they are supplementary, so they have to add to give me 180 degrees. So it's just some simple math from then. I got 12x minus 48 equals 180. I'm going to add 48 to both sides, so I got 12x equals 96, and then I'm going to divide both sides by 12, so I get x equals 8. And that's what the question asked for, find x, so I don't have to do anything else to it. Once again, I think the hardest part is just figuring out where to start, and you may have done it differently than I did and got the same answer, and it's all good. Okay. So I want you to try this one, see if you can figure it out. If not, you can, hit the play button and listen to me talk about it. But I want you to try it, and I want you to hit the pause button in 1, 2, 3. Okay, so the way I see this one is I see an inscribed quadrilateral. I know that the green angle J and the yellow angle L have to add to give me 180 degrees. So whatever J is plus 92 has to add to give me 180. So really quickly I could do 180 minus 92 and I get 88. So this has to be 88 degrees. And then some people know that a quadrilateral equals 360, so they subtract the three angles. Or you could just recognize that this is 45 and this is something, K. And those are opposite angles, so they also have to add to give you 180 degrees. So you could just do 180 minus 45 and do the same thing pretty much. So I got 135. So hopefully that's what you got. And if not, you can email me and we can talk about it. Alright. Okay. So I want you to try this one. And then whenever you finish, click play. So pause the button in 1, 2, 3. Okay, so first thing that I notice is that I have an inscribed angle and I have this intercepted arc. I don't know what that arc is, but I can find it because I know the other two are 92 and 162. So if I do 360 minus 92 minus 162, I get that this red arc is actually 106 degrees. And then I should know that this inscribed angle, the 7x minus 10, is equal to half of the red one. So if I do half of 106, I get 53. I'm going to do that in red just so you know that that's where that came from. And then I just solved the problem really quickly. I'm going to add 10 to both sides, and then I'm going to divide by 7. So I get x equals 9. Alright. So here's another one that you can try, and you can pause the video in 1, 2, 3. Alright. So I think this one's pretty easy. I'm trying to find W. I don't know why the thing's not working. There we go. WXY, that's an inscribed angle. I know that an inscribed angle is equal half of the intercepted arc. The intercepted arc is 62, so half of 62 is 31. So sometimes they're really easy and sometimes they're a little more complicated. Alright, so this is the last one that we're going to do. You can pause the video and try it by yourself, or you can just listen to me ramble on. Okay, so here's what I noticed first off. Do you see how this is making a semicircle? And then this is also making a semicircle? Or you can think about it as, if you remember vertical angles from Math 2, like these two are vertical angles, so they have to be congruent. These two are vertical angles, so they have to be congruent. So what I would do is I would just take the two arcs and set them equal to each other. And then find what x equals. So I'm going to add the 22 to the other side. And I'm going to subtract the 8x over. So I got x equals 17. And then it wants me to find just some different dimensions. So it wants me to find the measure of A to D. So that's here to here. And if I know that x equals 17, I can just plug that in. So 8 times 17 plus 12, I got 148. And notice that makes sense because I only have 2 letters, so I know it's a minor arc. It's got to be less than 180. The other thing it wants me to find is CD. I know that the yellow and the green are a semicircle, so really I could just do 180 minus 148, and I get 32. So I could do it pretty quickly. And then the last thing it wants me to find, I'm going to do it in purple, is B to D to C. Okay, so I can't go like this, because if you notice, I go through C before I get to D. So I have to go in this order, B to D to C. Also, the other thing is it's 3 letters, so I know it has to be more than 180 degrees. So I know that this one is 32. So I should also know that this one is 32 because they're vertical angles, so the arcs are going to be similar. And then I'm just going to add all 3 of those together. So I got 32 plus 148. So I got that purple angle, the purple arc, is 212 degrees. Okay, so hopefully this made sense. There's going to be some problems on haiku you can work through. You can watch Khan Academy videos. You can call other people for help. You can do lots of stuff. Y'all are doing a great job. I'm really proud of you. Okay, bye.